I think one thing just to start out just for stressing, I think, is to make the point that agriculture is the source of livelihood for billions of people, including something like 3/4 of the world's poor people. And their income and the growth of that income contributes not only to their own resilience, but to society's resilience as well. So as a result, enacting measures to build agricultural resilience requires not only sort of understanding of the strategies and technologies to reduce vulnerability to short-term shocks, weather shocks, et cetera, but also how do you generate the long-term growth in agriculture that generates that income that provides a much better stable buffer against shocks in the long run. So to briefly talk about that, I'm going to discuss some of the ways in which agriculture technology can contribute to resilience through enhancing crop yields and increasing farm income, while also protecting against those kinds of shocks and stresses we've talked about a lot, such as heat, drought, and pests and diseases, while also trying to reduce the pressure on natural resources. I think we probably all know here the future dynamics are going to put even more stress on agricultural and food systems. World population is going to increase by another 2 billion to about 9 billion by 2050. And all of that growth essentially is in the developing world. And I think something that a lot of people don't realize, 3/4 of the increase in population going to 2050 is going to be here in Africa itself. So that's the driving force that Africa is going to have to deal with in particular. Estimates vary, but we're going to need something like 80% more meat, 50% more cereals, and 40% more roots and tubers to sort of maintain and slightly improve nutritional capabilities over the coming decades. While doing that, that additional food is going to have to be produced while dealing with climate change, increasing water and land scarcity, and other environmental stressors that are developing. So to do that, of course, one of the keys is producing more food without further damage to the environment, and that results, as a number of our panelists have said already, that we need accelerated investments in agricultural research and development as an extension to get the new technologies out to the farmers. There's a lot of technology options out there that, as people have already stressed, that sort of transparent evidence-based support to look at decisions on where to invest and how to invest in these technologies has been relatively scarce. So what we've recently released a report where we tried to sort of disaggregate more that both the technology assessments and the sort of spatial and geographic analysis of those technologies. That was called Food Security in a World of Natural Resource Scarcity, the Role of Agricultural Technologies. So, it uses a combination of biophysical modeling and economic modeling, and to look at and prove one of AJ's points. In this particular study, we looked at rice, maize, and wheat, so we didn't look at some of the secondary crops and fruits and vegetables. We do have work underway on those as well. We cover a range in the assessment of traditional, conventional, and advanced practices. We stress, for example, farm-level management technologies such as no-till or minimum tillage, integrated soil fertility management, precision agriculture, but implemented with sort of lower tech and smaller scale than the ones you see in the United States and Brazil. We're also looking at irrigation technologies, including small-scale water harvesting, drip and sprinkler irrigation. Then we also look at crop protection, including both whether it's through integrated pest management or through additional, more efficient use of chemicals. And then we look at a number of technologies implemented through crop breeding, specifically embedded in seed varieties, and that includes heat tolerance, drought tolerance, and nitrogen use efficiency embedded in seeds. So let me just talk about a few of the broad results of that report, and then try to draw some conclusions on that. First of all, the report goes into detail about the individual impacts of those different crops, and you can get that off of the IFPRI website. If we look at plausible adoption pathways for these the 11 technologies that we examined here, It's projected that we could reduce rice, wheat, and maize international prices by 40 to 50% in 2050 compared to the baseline scenario where there's low adoption of these technologies. So that would essentially stabilize at least the average prices over the coming years compared to a baseline scenario with increasing food prices, which hit the poor very hard. Another key result is the savings of crop area for these three crops alone. You get 15, depending on the crop, 15% to 25% reduction in crop area in 2050 compared to the baseline, and that's because by the careful resource conserving intensification, you grow more food on less area, reducing the pressure to go into spreading crops into pasture areas or forest areas or other marginal areas. In addition, the assessment indicates that you could reduce the number of food insecure people by about 36% in 2050 compared to the baseline, so a much better result than without these technologies. Other key things is, of course, the technology impacts vary substantially by region. We look at all countries in the world, plus subnational estimates, so we go well below to sort of 60 by 60 kilometer areas within countries to do this analysis. It does give some results that I think that are very useful for targeting specific technologies to specific regions, countries, and subnational areas. And again, those kinds of assessments are now being used in our discussions with USAID and with several African countries through what we call the African Technology New Alliance Technology Platform for Africa, where we're working directly with countries to do even further disaggregation of those kind of results to look at how prioritization might be done. One of the key technologies is not just those sort of advanced irrigation technologies I showed, but just comparing irrigation without irrigation, that these other technologies tend to perform much better under irrigated areas, so that investment in irrigation comes off as a substantial area to expand as well. I think the technologies that address abiotic stresses, such as heat tolerance and drought tolerance, came off as very strongly positive, and of course the heat tolerance ends up being key to those areas that are hardest hit by climate change, and drought tolerant also tends to follow those kinds of dynamics. So those are going to be some of the most important ones in terms of adapting to the new stresses and new shocks of climate and weather. The improved land management practices have really large impacts in many of the regions, including no-till, when maintained over a number of years, builds up significant improvements in soil quality and enhanced yields, and also the precision agriculture and integrated soil fertility management come out is very strong, and ISFM is particularly strong in Africa, where it helps to develop the nutrient base beyond what we have now. Also, we find several of the technologies contribute directly to reduced environmental impacts. For example, drip and sprinkler irrigation end up with substantial increases in water productivity and savings in water that can be used also of course, to improve yields elsewhere, or else to be transferred to non-agriculture sector, where you're seeing, of course, a tremendous growth in demand for water for industrial and domestic uses, household uses. Let me then just move on to say that, so obviously this helps to show how to prioritize investments in technologies in terms of, and what the potential is of these many technologies. But of course, implementing these technologies on the ground is going to require institutional, policy, and investment advances in a number of areas. And key areas, of course, we've heard them from, I think, the other panelists, but is to continue investments in agriculture research and the development and extension of these resource-conserving farm management techniques, increase rural investment in rural infrastructure, including roads and irrigation, and improve regulatory systems for agricultural technologies. I think one of the key findings that, you know, compared to what I expected, the resource conserving management, which I think is some of the things that could best help small farmers, turned out to be extremely highly beneficial. But to get those benefits, particularly, we're going to have these expanded extension systems that we've heard about already. But I'd like to stress that not only do we need the reform of the sort of public systems, but I think we're going to have to rely on, given the status of those systems now, much more on community-based extension systems, NGO and social-based systems, as well as private sector initiatives such as the input hubs and full-service hubs that provide information as well as seeds and fertilizer, et cetera, to farmers. And finally, I think one area that we haven't touched on, and I'll wrap it up, is the need really for a sort of regulatory and governance reform in areas such as in seed systems in particular, but other input systems. That, you know, it's extremely hard to get new effective seeds out to farmers, partly because of sort of antiquated, and I'm not even talking about GM seeds. I'm talking even new hybrids, new innovative seeds. There's excessive regulatory pressure, excessive need to prove benefits prior to releasing them, rather than to, in a sense, let farmers experiment and determine whether these seeds are useful or not. So that kind of opening of these sort of governance systems, improvement of those would have a major impact as well.